For number 16, I'd like to discuss different types of mining, and I think different types of processing will also be in this study goal. Yeah, we're going to discuss processing as well. Um, now, there's 5 types of mining I want to discuss. I want to show you 5 different types. They're on the screen now. But before we do those 5, there's like 2 big basic concepts we have to get out of the way. Number 1 is mining is no longer the scale you think of. And this is interesting because when we talk to the general public about mining, most people imagine mining that they've seen in pictures when they did the California unit in the 4th grade, or in movies where they talk about London during the Industrial Revolution. That type of mining that you visualize doesn't exist. There might be a couple of random people digging little holes on the coast of Indonesia looking for diamonds or whatever, but there's basically nowhere on Earth. There's basically nowhere on Earth where this is done industrially. As a business, it doesn't exist. There's subsistence mining where maybe some people dig stuff in their yard, but essentially worldwide, the scale of mining has shifted, and there are not 4th grade field trips or popular movie references to modern mining. So the public doesn't know. Out of sight, out of mind. We really don't know how big mining is, but mining is big. This is not make-believe. This is not a digitally mastered image. This is an actual photograph of what's called the Badger 293, which is the biggest machine in the world. And you should definitely look this thing up. It's unbelievable. Thing weighs 31 million pounds. Like, you see that yellow excavator at the bottom of the screen there? That's not like the yellow excavator that you see out in front of the house when somebody's trenching to run new drains or whatever. Like, the scale of these machines boggles the mind. And so, like, if the machines are this big, and you should seriously go watch some videos. I didn't have time to embed videos of these machines working, but it's staggering. If you like, just Google this thing. It's just like, it just take a minute. Leave it on your phone later for when you have to take a dump, and go check it out later. These things are amazing machinery. And so, like, I guess if the machines are big, the holes in the ground might be kind of big. I mean, there was like a couple of decades there where we didn't even dig the holes in the ground. We would just blow up the tops of the mountains. The point I'm trying to make is that the scale of the problems is staggering. Mines are not what you think. There's another thing too, where most people imagine that a mine is like tunneling, like the dudes on the right of the screen here. That would be called subsurface mining, and it's very uncommon. Almost all mining today is surface mining. Imagine that there's like gold underneath the Met, or the White House, or the Eiffel Tower, or the Washington Monument, or the Vatican, or whatever you would value. If there's gold down there, like, maybe we should argue about getting the gold or not. And if we were going to get it, maybe we should try to preserve this giant collection of art, or this monument to governance in our nation, or this fantastic sculpture, or whatever. Funny thing is, there aren't a lot of idiots out there to argue the value of wetlands or of native forest or of salmon or whatever. And so subsurface mining, where you make a small hole and tunnel to reach a resource, that's precise. It makes a little pile of dirt, but it's really risky and really expensive, and it has a lot of humans with small machines. And that's the wrong equation today. Today, what we would like to do is just blow up the White House, push it over, and get all the dirt out of the way, because that's a few humans with a couple of huge machines, and that's the right direction. We prefer that. It's sloppier and messier. You got to wreck some White House or some paintings or some beautiful sculptures or whatever, but we get our cell phone for cheaper, right? Because it's way more cost effective to do what's called surface mining, where you have few humans. The most expensive part of the system is the human now. Let's minimize the use of human labor and optimize the fossil fuels because they're cheaper, right? Think of how expensive it would be to get all my labor to manually cut up a tree. You could replace 2 months of my labor with a couple gallons of gasoline and a chainsaw. 2 months of a human or a machine and a little bit of fuel. I don't know what the scale is for dirt, for rocks. Like, no thank you. We don't want a lot of humans with a few machines. We want a few humans and a lot of machines. So what used to be a precise surgical attack to make a little tunnel and reach a resource is now just a bunch of dust. Dynamite is also cheap. We used to do small scale, and we used to do underground or subsurface mining. But now we do huge scale and surface mining. There's 5 types of mining. You should probably know them. The College Board would likely ask you to compare them or discuss how one is better or worse than another. By the way, this diagram has some interesting interesting terminology. If you're interested in this, if you want to pursue geology or mining, this is a lot of educational content on this slide. Okay, placer mining is placer deposits. Placer deposits are stuff that was moved by water. So when the water slows down, things settle, right? Fast moving water can move big, heavy stuff. When that water slows down, the heaviest stuff settles first. Then when it slows down more, the medium weight. Then when it slows down more, the lightest weight. So you'll have 100-pound boulders, 50-pound rocks, 10-pound little rocks, 1-pound nuggets of rock, 1 ounce bits of gravel, 1/10 of an ounce fine grit, 100th of an ounce sand, right? As the water slows down, things settle based on their weight. And what's interesting is gold is really dense. It's like lead. So if you have 1-pound rocks and 1-pound nuggets of gold, the things will weigh the same, right? But then the denser material will go to the bottom. And so if you move aside, you'll get like a little layer of pebbles of gold that all weighed the same, but settled deeper because they were more dense for the same weight. If that's too much physics, don't really stress it. It's called placer mining. And because I'm talking about water moving stuff, you should definitely know that this is targeted at riparian habitat because you're along a river where the sediment is. Sediment pollution is likely because you're trying to make dust and separate dust. This is a primary driver of deforestation in the tropics, and this is a primary driver of development in the tundra at the remote polar regions, because there used to be rivers when the planet was warmer, and now they're all frozen, but the river deposits are still there. I don't know if that makes sense. Also, I'll talk about this tomorrow or later on today, but illegal mines are usually associated with mercury pollution. We'll get back to this later, but it's important that you keep this in your notes now. And you should know that placer mining is usually for gold and gems. About 1/2 of the world's gold comes from illegal mining. And this is one of the primary economies in the tropics. Brazil and Ecuador and Peru, and kind of Colombia, kind of Paraguay, Congo, Democratic Republic of Congo, the whole central tropical band of Africa, and like Indonesia, tropical islands around Indonesia. We used to do it like this, where you would just dig up the side of the river, divert some water, and that water would help you separate things by density. Very manual intensive right in the river. Now it's the same concept, just bigger. We use machinery to dig up a bunch of sediment. We use big tools to separate things by density. And you can imagine there used to be a river running right through here. But you stop the river, dig up all the sediment, and theoretically, hopefully, treat all of the runoff so the water going downriver is clean. If you're lucky, it depends on which country you're in. Like I mentioned, there used to be rivers in the tundra. Now that it's colder, the river is gone, but the deposits are still there. So there's a whole bunch of people that do this in Alaska and Canada and stuff. These are the world's largest legal mines of gold. But the illegal ones are the interesting ones. There's a lot of water in the tropics. So right at the foothill of the mountains, you can see the mountains in the background of this picture. Right at those foothills, you've had water that was moving really fast that just slowed down. So you'll find deposits. And if you can dig through those, you might find a lot of gold. If this is not a legally sanctioned development, you don't have to follow those rules about protecting the water, about protecting the habitat or the wildlife. And so these are some of the most profitable activities in the tropics. And thus, this is what the mob does to make illegal money in the tropics. It's not like drugs, and it's not like exotic parrots or whatever. It's the gold. This is the primary driver of deforestation in the tropics. It's the one reason that we get into virgin forest. Once the miners leave, then that network of roads is useful for extracting exotic pets, finding rare hardwoods. As more and more people have been through here, then it becomes relevant to maybe slash and burn for agriculture, but that's like down the road. That's after all the predators were shot and all the roads were expanded. It's dangerous and scary to be in the tropical forest. So nobody does that. Nobody penetrates into tropical forest to grow soybeans or raise cattle. We penetrate in tropical forest for mining. Remember, I'll come back to this later, but this is about 1/3 of the world's mercury pollution in total. It is the number one source by, it's the number one driver of mercury pollution is illegal mining, because gold is usually stuck to rocks, and there's a trick where you can use mercury to separate them. I'll describe this later. Remember the scale? Like, this is giant. It's so much money, and there's nobody there to stop you. So placer mining is done legally, but most of it is done illegally. And so this is where we get, maybe a quarter of global gold, but that's more than 1/3, almost 40% of total mercury pollution. Tons of workers involved. By the way, there's like a huge human slave industry. Like, why pay people well if you can buy slaves? You're already doing something illegal in a remote setting. So like this is one of the primary activities for human slaves worldwide. Like it's horrific, super gnarly, really interesting. Um, the main places where placer mining is done legally is like Siberia, Russia, China, Canada, like tundra. A few places where we do it in the US and stuff. But a whole bunch of it is a separate branch, the illegal tropical stuff. And that's the one that has the really big impacts on habitat and water and the mercury and, by the way, the human slaves. Okay. Distinction of the legal and the illegal placer mining. All right. Next is underground mining. This is the tunneling through the ground, the classical like pickaxes and carts, cough cough kind of mining. Subsurface, so this is probably the least impact you could have. Still are going to get acid mine drainage. We've talked about that. It's really difficult to keep the water out of those holes because water likes to go downhill. The human safety is a big whoop. Every time you hear about some disaster with miners, it's an underground mine. There was a big famous one in Chile. There was a big famous one in China. There's always big mining disasters in Appalachia that rarely make the news, but it happens all the time. Go to West Virginia and talk to people. It's like always going down. And we primarily do this for coal because coal is organized in sediment layers that sometimes get turned up sideways on mountains. So sediment formation, mountains means that those layers will often be turned like this, so you dig down it. So underground mining is usually for coal. There's other stuff. But like these guys and these guys and these guys were chasing coal. And today we just do it with machinery and we don't use the carts. But those are the seams, the layers that you're chasing in underground mining. Open pit mining is like it sounds, a big hole in the ground. You like drive down there, take out a scoop, drive it out, and then you do it again. So there's like some machines that excavate and trucks that move the stuff out. These are, relatively speaking, simpler, safer, and more profitable. Because, like, you just machines and less humans, and how many dollars are down in the hole, right? Like, I guess to move all that dirt, we just get trucks and dynamite and 4 guys to drive it for a couple years, boom. And so the math is pretty straightforward. This is the majority of metals worldwide. Obviously, we've got bigger impacts, right? Because now you're just removing all the dirt. Imagine if you just took that whole region of Washington, including the White House, to get really deep underneath it. So there's more spoils, there's more wastewater. But this is primarily for metals. And the United States has the world's largest hole in the ground. Keep in mind that there are like graded roads that go down there. You can see a little truck right over there. See that little truck? He's driving down. Here's a few other trucks. They're like, there's the excavation happening right there. So these guys are digging through this stuff and they load it on trucks and those trucks like drive out. And like, you've got a whole bunch of excavators and there comes a truck. But when your brain is scaling this right now. Like you can't help it. Your brain's trying to understand this image. And so your brain looks at the hole and is like, okay, yeah, there's a road and these are roads. And so maybe that's like a mile or something because like these are the roads. And you're trying to make sense of this, right? And so when you see that road that has a truck driving, you're like, oh, okay, well, the truck, road, I got it. But the truck is not the truck you're used to scaling. So that road is not the road that you were thinking. When you were looking at that road, you probably thought like, oh, mountain road, Camino Cielo, whatever, I got that. But no, no, that truck is way bigger than you thought. So the roads are way bigger than you thought. Those little trucks are like 6-lane freeway scale. So imagine these big old trucks, they're like big trucks. So now that you have a point of reference for the truck, then you imagine a road for two of those to pass each other uphill, downhill. Imagine the fuel consumption or whatever. And then you start to map in your brain these really big holes in the ground. We're talking just giant scales, like millions of tons of dirt and millions of gallons of water generated daily, and like bazillions of pounds of CO2. And yeah, we get a lot of metal out of that. The global economy is huge, and we get a lot of money out of that. I just don't want you to dismiss the global importance of this topic, because these are big holes in the ground or big strips torn out of the ground. So instead of digging a hole down, we can also just remove a whole layer. This is the most common way of getting coal, because coal is sedimentary. So if you have a stack of cards and there's like some good stuff at the top, you could dig down, or you could just remove those whole layers. So we're talking big volumes, because you're just getting a layer of sediment near the surface. And remember that because this is coal, there's especially important problems associated with coal, hydrocarbons. Like, you could wash out a bucket, but if that bucket had gasoline, now you've got a bucket full of nasty water that touched gasoline, right? So the secondary pollution, like the chemical reactions after those hydrocarbons are washed away, that's really serious. So you understand this, right? Like, strip mining, you get a whole layer. Big machines, big layers. I'm going to start repeating myself. Don't forget to look up the Badger. These are the previous Badger, the Badger 288. Now we're up to the Badger 293. Look at the size of these machines. God, it's just crazy. All right. And the last type of mining technology we should talk about is called mountaintop removal. It's just like it sounds. You remove the top of a mountain. Since sediment forms in layers, sometimes there's sediment layers that go across the entire landscape, right? Like, imagine if these layers had been eroded by rainfall, you would have mountains where there's a layer that kind of shoots over to the next mountain where that layer continues, right? You have a bunch of layers, and then erosion happens, so they have a common layer at the bottom. And so in mountainous parts of the world, you could try to tunnel through the mountain to remove the coal layer, but we figured out this really crazy idea. What if we just explode the whole mountain and move it out of the way? This was illegal. And we had a president who was like, yeah, but maybe the law says something different. Like, I don't have to protect that river if the river is gone, because you have to put it on a map for it to be a river. And if there's no more river, well, the clean water laws don't apply. And that was eventually overruled by the Supreme Court, but it took a while for that to happen. So we had in the United States like a 6 or 7 year period where we issued a bunch of mountaintop removal permits. It was gnarly. This is pretty much illegal now, but people have done the math and like, holy crap, we can do this. It's just a few machines and a lot of money. It takes literally just a few bros, like team of 4, 6, 8, 12 people to make like billion-dollar mines. So the machinery is expensive, but you just don't need that many workers. And workers are kind of the weakness in the system, so the scale makes sense. We just blow up the whole mountain. The amount of stuff is crazy, and you're reshaping the landscape. You take mountains and you just knock off all the tops. That dirt has to go somewhere, so you fill in all the river valleys, and you make like a parking lot with little exposed bricks of coal. The impacts are by far the largest of any type of mining. Check this out. you can see where the mountain used to be, and you just move all the dirt to fill in the valley. Then you've exposed that coal and you just drive it away. This is the biggest, largest type of mining. It's the most profitable. It was only done for a while. It's mostly illegal, but now that people know that it was doable, there's other countries that are like, well, we don't have those laws. And so this is one of the ways that American technology development becomes globally a bigger impact. You can see here's the layer, and all of this dirt used to be up on there. All of this dirt here used to be a river. All of this dirt used to be a river, but now we just fill that in with all the dirt that used to be up there. And now you've exposed this. So these guys just drive up and they just chip away a little bit of the coal. And so you kind of make a readily accessible strip mine, right? By just removing all the dirt from the top. You just blow it all up and push it over. And I got pictures, but they don't really impact my students because a lot of you don't spend a lot of time looking at the mountain landscape. So when I show you this, it's kind of like, okay, Jose, whatever, man, it's a mine. And it doesn't hit you the same way that it hits me. But when I see these, I think like, that's not what that should be shaped like. That should have contours and there should be rivers running through all of that. And the impact that this has on rivers is massive. All that water has to go somewhere. So now we've got sediment pollution and acid mine drainage that we're holding up with dirt dams, and people live there. So this isn't just some esoteric thing about the environment. I also think about these communities. Here's your mountaintop removal site. You can see all of the graded and moved stuff. Here's your earthen dam, where presumably that water will be treated before release. And then here's where people live. Here's a city. Here's another one. You can imagine if this thing breaks, right? Tidal waves of toxic mud, and that happens. It happens in Appalachia, like 1 or 2 a year. It's actually common and it's horrifying. Okay, done with mining for now. I'll have to make a separate slideshow about processing, but I think I'm done.